All right. Hi, everyone. Thanks for joining us for our live Tech Talk session. My name is Grace Yoon. I am the social media manager and marketing lead at the Chicago Connectory. If you're familiar with our Tech Talk sessions, welcome back. If you're unfamiliar, quick background information about the Chicago Connectory. We are a co-creation space and IoT incubator. Our community is filled with amazing startups, partners, collaborators, and mentors, all with IoT backgrounds. Together, we host and create these amazing virtual sessions, such as this one. I'm joined here today with David. So thank you so much for joining, and David, take it away.
All right, welcome. My name is David Castillo. I'll be with you for the next hour and a half. Thank you for attending. I hope this will be an interesting talk for you. This is the second time I've delivered this talk, and it's kind of evolved since the last go around. So if you did participate last year, there's some new material I think you might find interesting. I'm going to try to practice my whiteboarding skills a little bit, so we'll see how that goes. Also have some demonstrations, a simple little app that I developed that kind of, I think, brings together some of the concepts and whatnot. I should mention that I'm not affiliated with Bosch, but I have a very deep relationship with the company as well as the Chicago Connectory. But I'm an independent IoT consultant based out of Austin, Texas. And with that said, let's go ahead and get started. Let me change up my little view here. Okay, I will go ahead and, oops. There we go. This talk is really about IoT. And I think the serverless part of it is really because as I have worked to design and develop and implement IoT solutions, I found myself more and more moving away from traditional infrastructure to then more what you might characterize as microservices, and more specifically like functions as a service. And in doing so, I'll be introducing a variety of different services on the AWS platform. I'll also walk you through some of the concepts of what really I think IoT is, because I think some people may not have real familiarity. So I'll start with that. And then we'll get into some demonstrations. I hope for the last hour of this talk to be really about, actually seeing development, working with APIs, working with some code, but it's not really designed to be very, very deep dive. It's really super high level. So with that said, I'm going to start with, hopefully you can see my whiteboard here. It's actually a little just tablet that I have in front of me. And I just want to talk a little bit about how I see IoT in general. And, you think about little devices kind of down here in the field. These could be things like Fitbits. They could be appliances. They could be whatever you might imagine that you could connect to the cloud. And I kind of see, the cloud is this data center that really no one knows about. And the story is really about how do I take the data off these devices and get it into the cloud, A, and then B, once I have it here, what do I do with it? There's a lot of things that we really need to do with telemetry coming off these devices. And it's really a game changer as far as product development and those kinds of activities. Because we can now deliver firmware back to the devices if we need to. So we actually evolve the products as they're connected. So I'm going to be talking mostly about what happens in the cloud. We'll be looking at API gateway as a service. We'll be looking at Lambda, which is a functions as a service. We'll take a look at S3, which is just object storage. We'll look at a couple of others, but hopefully you'll kind of see where I'm headed with this talk. Before I get started though, let me just kind of paint a picture, if you will, what traditional kind of cloud-based development might look like. And this is, I think, going to lead us to the logical conclusion that service really does make a really good idea. So about 10 years ago, I launched EC2 instance. If you're not familiar with EC2, it's a service for launching virtual machines on the AWS cloud. And in doing so, it was a fairly straightforward process. It came with a public IP address, and you launched it, you configured what was called a security group at the time, and pretty much I now have a server running in the cloud. Well, things have gotten a little more complicated, and now we basically operate within what's called a VPC, which is kind of a virtual network, if you will. And this gives you isolation. It enables you to protect your applications with a variety of different tools. You'll typically now develop your solution, excuse me, in what are called multiple availability zones. So these AZs are a way of kind of putting your infrastructure in different geographical locations, different grids, electrical grids, different floodplains. So it's really designed to give you high availability. And then you have inside of those VPCs within those AZs subnets, right? Subnets. And some of these will have your web front end, for instance. So I might have multiple web servers running in my public subnets. And then I might run a database, let's say, in my private subnet. So I'll just say private, right? And I might even create a secondary database just in case my first one fails because I want high availability. So then my traffic comes in, you'll put an internet gateway here. You'll have to construct route tables to give traffic through that gateway. You'll put security groups, you'll put network access control list. There's a lot that has to happen to deploy a single application in a traditional cloud-based approach. So what you find is that, rather than developing your product, which is really where your business value is, you're spending a lot of time spooling up infrastructure and learning how to configure it. And it's a perfectly legitimate way of deploying applications. But what's kind of happened over the years is Docker came around. When Docker came around, it was kind of a game-changing technology because it really made it very, very simple to develop applications that were kind of single purpose rather than a monolithic application. And I kind of think of like a Docker cluster is just one big giant computer with a lot of compute and a lot of memory. And when you spool up a Docker container, it's like a virtual machine. It's a little bit more lightweight, and it has all the environment necessary in order to run your application. But I basically give it a compose type file. If you're familiar with Docker Compose, it's just a little file that says, spool up these 3 little instances that have little applications running on them, tie them together, and put them in this cluster. And then when I define it, I just tell them how much RAM they need and how much compute power they need. And then automatically, using orchestration service like Kubernetes or ECS on AWS, it just magically makes these things happen. So that got really, really powerful. But then Lambda came around. And Lambda is really, really interesting because Lambda basically allows the developer to just write their code, not have to worry about containers, not have to worry about a cluster for Docker, not have to worry about EC2 instances, not have to worry about network configuration and whatnot. You basically just write your code and then magically you deploy it and you pay as you use it or for execution time. So in a traditional kind of IT world, like let's say on-prem, you would buy a server, you would maybe buy 10 if you had a larger application, and you may not even use 10, you might use 1 or 2. So you really had a big capital expense. And then over time, you might grow into that. And then if you needed more, you have to provision some more. So on-prem was really, really difficult. The cloud, because it's so elastic, you really have a lot more ability to kind of grow it and contract it based on actual traffic needs. So on-demand really made it a game changer to spool up. You had less risk. You could basically get things going. If it didn't work, you tear it down, no penalty because you basically pay by the hour. But with functions as a service, you really, I'm going to switch back to my title screen so you at least have something to look at. Give me 1 second here. Yeah. You basically, with functions as a service, don't pay until somebody actually calls that Lambda function. And that gives you like sub-second billing. Basically, if nobody calls your Lambda function, I've had Lambda functions in my account for years, and I'm not paying anything for them because I'm not really actively hitting those Lambda functions. So it's a really easy way for startups, and in particular IoT startups, to really build some powerful solutions that have back-end persistence on a database, but really you're paying minimal infrastructure. Amazon as a service offers a free tier. So when you get into the environment, you get your account, you can do a lot of experimentation with very little to no cost. And that was really something I think I enjoyed the first year. But really because the way I now design these kinds of systems, I really don't have to worry too much about a big bill until my application gets a little bit better, people start hitting it a little bit more, and then you start to pay a little bit, but it's all like fraction-based compute. So with that said, let me jump over to my other computer here because I want to basically walk you through a little application that I designed. And it covers a lot of different services. Give me one second here. Okay, here we go. So I'm in my management console. So when you log into your AWS account, I'm going to share my screen. Turn that off. Where are you? Oh, here we go. One second. Got to kill off my PowerPoint. Okay, now you should see my management console here. So when you log into your Amazon account, you will see that there are a ton of services. Many of these are like traditional compute, cloud compute, where you have launching instances. But what we're going to really look at is a service called Lambda. And I'm going to start by demonstrating a little kind of simple application that I developed, and then I'm going to walk you through how it all ties together. So I'm going to start by going over to a service called Cognito. And Cognito, if you're not familiar with it, is an authentication and authorization system. And it really does a lot of the heavy lifting for you. So it's super, super simple to get started. You have manage user pools. And a user pool, think of it as a collection of users for a single application. And to create a user pool, you're able to do things like, put a password policy that says, you have to have 8 characters and one of them has to be uppercase, another has to be a special character, that kind of thing. You're also able to assign your users to different groups and then assign those groups a role, and a role would have certain permissions. So maybe you have 3 different user groups where one just has the ability to read data from your application, and maybe an admin role has the right to actually do other kinds of things. So you can actually manage your users for your applications in a user pool. I'm going to show you one that I've already got going here in Oregon, and I'm going to kind of walk you through just the basics here. But you can see that I have down here a little URL that I'm going to hit. Okay, this is basically providing me a place for my users to log into my application, and I'll just go ahead and do this. Oops. Okay, now all this did was authenticate me as a user and provide me what's called a JOT token. It's kind of an OAuth token. That's this long thing up here. It looks kind of crazy, but this is what I'm going to use. This is my simple little ugly app. I'm going to go ahead and copy that. Whoops, got too much of it. Hold on. I'm going to copy that, copy, and go over to a website called jwt.io. And if you scroll down, this is a service where you can actually just inspect it. This isn't encrypted. It's just what you might say, hold on one second here. All right, so this is what you find inside of a JOT token. It's base64 encoded, it's not encrypted. Anybody could crack it open and look at it. It basically says in here that the username that I logged in with is D. Luis Castillo. It says here's my email address. It has some things like I've been verified, has a group here. I put myself into a group and I assign myself a role. And this role is what's going to give me permissions to make API calls. So the first service that you're probably going to want to look at when you build an application that's serverless is how are you going to authorize and authenticate your users. Now, this little application doesn't really do too much, but I just wanted to show you that. But it actually does. This is running on a service called S3. And S3 is object storage. So it's a way to just store things that might be video files or media files or MP3s, whatever you want to store there, you can, and it's a very, very durable service. So that's why a lot of people like to use object storage. It's very cheap and it's very durable. I'm running this little web page. It's a simple little HTML file inside of S3 and configured that what's called a bucket to host a static web page. So that's how I'm able to hit this. So when I authenticated, I make an API call or an HTML call to get the one page document, which is this little application. And it does have some functionality to which I'll show you. I authenticate it, and I'm going to use this token to basically hit the back end. So if you pull down this page, which is publicly available, you could see the page, but you wouldn't get the token. And without the token, you couldn't hit the backend infrastructure. Okay. Now, this little application is using about 3 or 4 different services. And I really think what I'm trying to do with this is just use it as a launch point to start thinking about, wow, I could really do that with, I could build my whole application in serverless and not have to pay for a computer, or not have to pay, for instances running for days or hours. I basically only pay when it's actually doing something. Okay, so that's kind of Cognito, authentication and authorization. And I think too often people get the two terms a little bit confused. So let me just try to spell it out for you. Authentication is really about you proving that you are who you say you are. So when you go to Google or you go to Facebook or you go to Amazon.com, you basically provide a username and password. Typically, they'll verify your email. And then when you provide that username and password, they're authenticating that you are who you say you are. Now, just because I now know who you are doesn't mean you have any permissions. That's authorization. And authorization is really about saying, now that I know who you are, and you've proven that to me, what am I going to allow you to do? And we do that with a permission service like IAM on AWS, or even in Cognito, I'm using roles to basically assign to my different user groups to give them permissions. Maybe they're just general users or admin users, they'll get different permissions. And that's kind of how Cognito works to support an application's front end. Now, let's go look at another of these services. Now, this is really that one little page after I authenticated. This is just sitting in an S3 bucket. Like I said, that's object storage, so it's just a simple little HTML file. When you run something on a service like S3 as a static website host, by static, we really mean it doesn't have any underlying compute. But guess what? It can. And it can because you can make an API call from a web page sitting in an S3 bucket. And that API call could hit a backend database and grab some data and then bring it back to you. And that's really what this application is going to try to show you. So the second service I wanted to go look at real quick is, and this is kind of an interesting one. And then we'll go to look at Lambda. But let's see. Now go here and jump over to the second service over here under application integration. And this is one, if you start developing applications with functions, you're going to realize one thing you can't do with functions as a service is really maintain state. And the reason why is these things really only live for the life of your execution. So when you call a Lambda function, it's not going to save any data. It's basically going to fire off some code, it's going to do something, and then it's going to die, and it doesn't persist. So you really can't save state in a Lambda function, which is really why they created this service called step functions, Amazon step functions. And it's a really interesting service. And I'm just going to show you this one little state machine and kind of walk you through what it is and what it does. But it's actually pretty easy to look at. If you come down here, I'll just go into this little editor environment, and you'll see that I've got this little state machine, okay? Now this state machine, the way it kind of works is we start what's called an execution. So I'm gonna trigger this little state machine, and when I do, it's like one user started the state machine, and if another user came, they would start a different execution of this state machine, and it's super, super simple. So what I'm really demonstrating here is a little application for like a parking application. And if you just imagine you go to a web app and you see a map, and on that map you see pins where there's parking spots, right? And those pins convey, let's say, 3 different colors. And one of those colors indicates that it's occupied. One of those colors says it's in a pending state, and pending would be they paid for an hour and they're in their last 10 minutes, say, so that spot will be available in 10 minutes or less. And then the third state is that you have available spots. So if you had this parking lot application, you click on one of those buttons and you see that it's going to be available in 10 minutes. You drive over there, you grab the spot. Trust me, I lived in San Francisco. I would have loved an application like this because it's really, really hard to find a parking spot in downtown San Francisco. Now, to construct this, you use this language. It's not too complicated, but I hope you can see it well. You start off by defining the state. So you can see here states. Call this one make in progress. And it has right here a resource tied to it. You can see it says right here function. And this is basically when it fires off, it's going to trigger a Lambda function, right? So this execution has some behavior to it, but it's going to fire off this Lambda function. And that Lambda function is actually going to take some information that the user provided in that little application, and I'm going to show you how this works, and it's going to store it into a little table. And that table is another service we're going to go look at in just a moment. So let me just walk you through one of these. I think this will start to make more sense. I'm just going to give it an artificial, random number for the execution ID. I have right now 3 or 4 spots in my parking lot. So I'm going to go ahead and put, 1111, and I'm going to ask for, let's say, 30 seconds, right? So this would be my little application, and maybe I have my PayPal configured for it or some other pay service, and I just bought 30 seconds of parking lot time in this little application, and then I trigger start execution. So if you come over here, you see how it gave me an execution ARN. So basically it says, okay, we started that little execution for you. Now here in the service, if I go back to my little application, you'll see I have an execution now running, right? And that running state execution gives me some telemetry about it, or not telemetry, but some, visualization of what state it's in. So it's in this make in progress state. It fired off this little Lambda function. That Lambda function basically stored that information into a table so that it updates the map and basically now shows that parking lot. I took it, I bought it for 30 seconds, and it is now unavailable. Now, after a period of time, this has a little timer inside that's based on your you requested, let's say, an hour. The last 15 minutes, I would basically have it go into this kind of pending state, and it waits in that pending state until that last 10 minutes. So this is how we're able to inform the user of the application what state that parking lot is in. And then ultimately, when this times out, you'll see that it completes the execution. So this service is really interesting because this gives you the ability to manage state, and design your flow outside of what you're doing with Lambda. So let's go and just take a look at Lambda real quick and kind of walk you through what's going on there. So I'm going to go back and look at my my little syntax here, and this function is called update status. So I just want to walk you down to Lambda and pull up the console and take a look at that Lambda function, and let's just look at what it's doing. So I'll go over here, I'll click on that, and we'll just say Lambda is right there. I'm going to go ahead and open this in another window. There we go. All right, so here's the Lambda console. It's just loading up. I think because I'm streaming, it's probably taking a little longer than normal. Let's see here. Here we go. And I'm going to search for that function called update status. And here it is. And we're going to go in there and open this up. And you'll see that this is just a little bit of code, doesn't do a whole lot. And this is what we mean by functions as a service. So I don't have to pay for this Lambda function being here until somebody actually calls that state machine, and that state machine then triggers this function. So if I scroll down here in a moment, I can click on this little script file, and you'll see that all this is doing is it's passing in the event right here, this event, and that event has that parking lot number, and it has the time that I requested, and then it's making a API call to the service DynamoDB and updating a table. So that's where we're actually storing the state of this particular parking lot application. But this is not a lot of code. We're talking like 50 lines of code here, and some of these already commented out. So it's probably about 45 lines of code, and I've got some behavior that I only pay for per execution. So now let's just jump over to the other service that I wanted to show you, which is a one that I find myself using often, and I think I should probably make a something clear because I think a lot of people get confused when we talk about serverless. I forgot my serverless does not mean that your applications are not running on servers. They are running on servers. What it really means is that you're not responsible for maintaining those servers. You're not responsible for security patches and updating those servers. That's all managed by a cloud provider like Amazon. And then you, as a developer or startup, only have to worry about your business value, the code that you write, and deploying it. And that really makes it not only less expensive, it really helps you to increase the velocity of innovation of your solution. So I'm going to just go over here to my tables, and you'll show you this little parking table. And if I come over here to items, you'll see that I've got a parking lot here in Texas, got one here in Arlington Heights, and so forth. And you can see that they basically all say available at this point, right? But I could have 10,000 if I wanted to, and have a map that displays all those different states. So I'm going to go back to my little execution thing here. I'm just going to give it a different number. I'm going to go to that same one here, again, 30 seconds, and hit start execution, and it did succeed. But now if I go over to my table and do a refresh here, you'll see that now that went into in progress. So really here's where my application is storing the state of all these parking spots. But what has only happened is that I made an API call. It went over to my start execution in my step function. It started that process and triggered a Lambda. That Lambda took the data that it was passed and it stores it in this table. And now my table is where I persist the state of my application. And if I just wait a little while and do another refresh, you'll see it now has changed to pending state. And this is just another one of those executions. So that's kind of how this process works. Um, I could go a little more into this. I think the one thing I think is interesting is that if you actually go to the execution, I'm going to jump back here and go look at that execution. You'll see that the input provided to this execution, this is what came from my little web page called Ugly App, and it sends this little JSON payload. And this JSON payload is just saying, how many seconds did I want to reserve and what was the parking lot spot, right? So these little payloads are passed through this state machine. And when I go off and I make a Lambda call, that Lambda call runs that code and then returns something, and that's passed to the next state. So you're really able to chain together these little simple Lambda functions to build out your application. Okay, well, there's one other service I want to touch on, and then I want to talk a little bit about really IoT, because I have found that building IoT applications, I find myself often using these same services over and over again in just different configurations. So it's really been a pretty easy learning curve once you understand that you can build a serverless application with just 4 or 5 different services, and they're really, really simple to learn. But the last one I wanted to show you is, go get that. It's called API Gateway. API Gateway. And this one is really where I'm able, an API is nothing more than what's called an application program interface. It's the way that my web page is going to interact with these cloud services. So I have this API Gateway. And you can see that I have defined a resource, just called it workflow. And then I have a post request. And a post request, if you're not familiar, is just a request that you can make from your application, just like a GET request that you make in a browser. So when you basically put something in this URL in your browser, you make it a GET request. And when you make a post request, you just pass it a little JSON payload. Okay, so this has got a little JSON payload that I'm sending it. and it's tied to that step function execution. So basically, when my authenticated request from my little application hits this API and it sends that little bit of data, it authorizes it against Cognito to make sure you're legitimate user of my application. And then it passes it on over here to step functions. And then step functions returns a response that goes back to the client. And that's what you were seeing here into this return. So this is what I got return. It says, okay, I've created an execution for you so the application knows that it was successful. So simple little app. I'm not done with it. I'm just using this as kind of a little demonstration piece. But what I am working on now is the visualization part of it. And there's another service that I really have just started beginning to work with called location services. And really, it's the ability, kind of like Google Maps or Esri or Here. These are a lot of companies that provide maps as a service. Location services, interestingly, uses both Esri and Here in the back end, but it's really got a really interesting set of APIs for a developer to work with. So I'm right now just going through that process of learning how to work with location services, and then I'll kind of complete this process. All right, so that's my little serverless, I guess, exposure, if you will. I know that's fast. It covers a lot of different things. We don't really have a two-way conversation here, but if you would like to ask a question, Grace is standing by, and feel free to just put it in the chat, and I'll give you a minute or two to put your questions in, and I'll try my best to answer it. And if you want to go back and explain anything in more detail, I'll do that as well. Okay. Well, um, other thing I wanted to do today, if you would, is kind of introduce you to this little thing I have going on here. Let me see if I could switch my camera. Right. So we are in the process of preparing to deliver a IoT Foundation series, and we've done this before, so this is our second go at it. But I really wanted to just talk a little bit about the IoT in the serverless IoT and how these things all fit together. So if you're not familiar with like an Arduino, these are all kind of boards that I have to basically they're prototyping boards. And when you start to work with IoT, let's just say you have an appliance or a product that you want to connect to the cloud so that it can send telemetry and that it could be actuated by, let's say, somebody operating a mobile phone, for instance. You would buy one of these development boards. This is a TI board. I use this in my third session, or excuse me, my third session to talk about device management and over-the-air deployments and those kinds of things. This is my ST board. It has a bunch of sensors on it, so it's kind of cool to work with. This is my favorite board. It's the Bosch XDK. I like it because it just has everything all inclusive. It has a battery inside. It has Wi-Fi capability. It has what else? Bluetooth. It has a thermometer. It's got just all kinds of really interesting things there. And I want to demonstrate that a little bit as well in more detail. It's got an accelerometer, a gyrometer. It's got light sensors. So I've got all these different sensors. It's got a couple of push buttons here, which you typically want to have something that you can actually interact with and then send messages to the cloud to make sure your telemetry is getting there. It's got some LEDs on it. So it's really just a nice little unit because none of these other boards really have batteries. And then this one is kind of one by NXP. That's kind of a prototyping board for building kind of Alexa into a product. So I probably have 30 boards at this point, and I have all different sizes and flavors, different companies. They all have their different attributes. But what these boards are really designed to do is to give you a platform to start prototyping out your product. And the thing that probably took me the longest to really comprehend, which is why I want to just talk about it briefly, and I go into deep dive on our foundation series. So, I mean, I crack open different workbenches and we'll actually write some code and deploy it to the board and see LEDs go on and whatnot. So I really can't get into that much detail on this talk, but the one thing you'll see here, just looking like at this one, for instance, is that you have all these pins on it, right? And over here, you have kind of an Arduino header. Let's see, on that one. And even on the Bosch XDK, you kind of have this little, you plug a cable into this and then you can tie it into a breadboard, right? And what's what that's about is what's called GPIO, general purpose input output pins. So conceptually, what is IoT really doing? Okay, it's got sensors, right? So sensors you could think of as inputs to some compute that's living on these boards. So these all have some Cortex M series processor. These are little tiny microcontrollers. They're very, very inexpensive, which is why everything's getting connected these days, including light bulbs are getting connected. But for these processors to really do anything useful, there's a couple of things you have to do. One, you tie these inputs to, or your sensors to these input pins, and they can read signals. So they're going to read either like digital 1, digital 0. So it could be like a switch is on or off. It can also read in analog signals in current and in voltage. And think of like a thermometer. A thermometer isn't an on-off thing. It's a continuous, value of data. So it could be like 77 degrees. And what that 77 degrees translates to is a voltage. And that voltage then gets to the microcontroller. The microcontroller can say, when the thermostat gets to a certain level, then go ahead and flip something off or flip something on, like your air conditioner, for instance. So you have those input pins, and then the output pins, they're very, very low voltage. So they're not going to power anything. And these boards, they can power like little LEDs because these are really low voltage LEDs. But what those little voltage kind of signals do, if you will, on the output pins is they can actuate other things, right? And those other things could be motors, they could be stepper motors, server motors, they could be lamps, they could be, anything that has an on-off switch, basically you can actuate. This is really how home automation is getting constructed. So that's kind of what these little boards are about. Like I said, in the IoT Foundation series, we go pretty deep into most of them. We look at actually how to read data off these sensors on these prototyping boards. We look at how to command and control using some of the capabilities of IoT Core on AWS. And we even look at sending the telemetry. So I'm going to do one little quick demo here that I think will kind of solidify these concepts a little bit more. Let me switch out my my laptop for a second. One second. So when you buy a Bosch XDK, you get this little application. You could download it from the App Store. Let me see if I can pull it up real quick. Okay. Okay, here we go. So you download it, install it, and I'm going to turn this little board on. And in my little application, if I go back to here, you'll see it kind of connects to it via Bluetooth, right? And now that I've connected, when I move the board around, it actually is sending that telemetry data to this mobile app, and that's making it change. If I just click on this button, it'll kind of reset its state. So you can see how I move it that way. So I'm moving my physical device, and my mobile app is demonstrating that where I moved it to. If you also look here, let me kind of see if I can do picture in picture here. Give me one second. Nope, not that one. Oh, whoops, oops. Don't hit that button. Give me one second. Okay, here we go. So I want to show that. And that one. Yeah. There we go. Getting closer. I got too many buttons on this thing. Here we go. So you can see I move my board and it's moving my device, right? And you can see on right about the right-hand side, second one down, if I cover it up, you'll see its value go to 0. That's the light sensor. If I move my hand, you'll see it go up. You can see like the little speaker on the right-hand side. When I'm talking, you'll see it's registering the value because it actually has a microphone on this little board. And you can see that I can even go in and look at visualizations just by picking what value. Let's say I want to look at temperature. And if I come over here and put my hand over this board, it's going to just start rising in temperature. And then if I take my hand off, you'll see it comes back down. So that's really, I think, the extent that I want to get into today on sensors. But sensors really are what drive a lot of what we call IoT. They're sending telemetry. That telemetry could be, the health of certain components within the device. And this is a real game changer because what you're going to find is that if you're in the business of selling anything that can pass electrons, you're going to want to connect the device, because if you don't, somebody else is going to, and it's going to really add some value to your product. And just to stay competitive, I think what I'm finding is that a lot of companies are really recognizing that they got to pretty much start exploring about how they're going to connect their products. Okay, let's go back. All right. And I'm going to go back in here. All right, so that was kind of the short version of this. Normally we have a Q&A, but given that this talk is really kind of just live stream, really don't have any opportunity to take questions. But I'll give you a couple of minutes. If you have any questions, feel free to ask. I'm going to go ahead and log back in here.
Hi, David. Looking at the comment section, we don't have any just yet, but I will let you know if we get any.
All right, no worries. Okay. Well, again, the series is going to start on April the 8th. If you have any interest on IoT, this is a really good foundation, I think. We've really put a lot of effort into, preparing demonstrations, and it's very interactive. So it's a little different than these kind of live streams, because we really provide you kind of a platform and an environment to tinker as you learn. So that's kind of always interesting. We're going to have it every 2 weeks starting on April the 8th. And there is a registration process through the Chicago Connectory. This is all kind of membership value driven. So feel free to register for that. We don't charge for any of these sessions. They're 2 hours each, and they go through quite a lot of detail. So this talk was really just intended to kind of whet your appetite about some of the different services that we use when building solutions for IoT products. Wanted to show you some of the boards that we're working with in the class. And we'll probably do a fair amount of kind of demonstration code, so it's a little bit deeper dive. But if you think you might be interested, just contact the Connectory and they will get you all signed up. And I think we're at 45 minutes, Grace. And if there aren't any other questions, I think I could just leave it here. Thank you for your time, and I hope that you will consider participating in the webinar series that starts on April the 8th on IoT Foundations.
Sounds awesome. Yeah, just like David mentioned, continue to follow us on our LinkedIn, Facebook, Instagram, Twitter channels, and you'll be able to register through the links. But yeah, thank you again, David, so much for this time and for the session, and looking forward to the IoT Foundation series.
Great.
Thanks, everyone.